Good morning, ladies and gentlemen. Welcome to our presentation. First of all, thank you for taking your time to watch this video. Let me introduce my team. I'm Phum Yuson, and I'm here with my members. They are Kitima Chersuriya, Narusha Jain, Purinat Nilamai, Amatsuki Said. We are third-year students in the Faculty of Engineering in Electrical Batch from King Mongkut Institute of Technology, Lakabang. The topic of our presentation is what's the best way to produce energy from hydrogen. As the demand for energy continuously increases, alternatives to fossil resources must be found to both prevent fossil source depression and decrease overall development impact. We present an analysis of the current methods of biomass conversion to extract biofuels and biologically produced gas to then be used in fuel cells. We refer the content from this journal, Systematic Analysis of Biomass Derived Fuel for Fuel Cell. Pathway that we study for converting biomass feedstock into fuel cell. Fuel select here were anaerobic digestion and gasification. Hydrogen can be used in fuel cell to generate power using the chemical reaction. We can apply it in many ways, for example, portable or power in-house. But in our presentation, we will focus on applying it in cars. We have divided our presentation into four main parts. First, we will give you an overview of hydrogen production to give you the basic knowledge required. Second, we will tell you about methodology of hydrogen production. Third, we will show you about the finding of best way to produce hydrogen. And finally, we will show you how this knowledge can be applied to fuel cell. Let's now begin with the first part.
First, I would like to give you a theoretical background of hydrogen fuel cells. What is the best hydrogen production? The first method is anaerobic digestion. Anaerobic digestion is a series of biological processes in which microorganisms break down the livestock manure, municipal wastewater solids, and food waste in the absence of oxygen. One of the end products is biogas, which is combusted to generate electricity and heat, or can be processed into renewable natural gas and transportation fuels. The efficiency of this process is 75%. The advantage: first, it is a closed system, therefore reduces odor. Second, sunlight from organic digestion is used as organic fertilizers. Third, it is much less likely to cause environmental pollution than spreading untreated organic waste on land. The disadvantage: first, not able to degrade waste such as wood, plastic. Second, if run inefficiently, anaerobic digestion can cause an odor nuisance. Third, organic degradation takes quite a long time. The second method is gasification. Gasification is a process that converts the fossil fuels organic waste into these gases. These gases include hydrogen, carbon dioxide, and carbon monoxide. The process involves oxidation and reduction of the organic matter at high temperatures, which triggers a reaction that spreads the hydrogen. The process is intensively used to generate electricity in various industries. The efficiency of the process is 65%. The advantage: first, allow the operator more freedom to adjust to the price and availability of various kinds of feedstock. Second, utilize to low-price feedstock such as petcoke and coal. Third, neutral carbon dioxide. The disadvantage: first, Fluctuating hydrogen use because of feedstock impurities. Second, seasonal availability. Third, information of tar. Next, we will show the process of an anaerobic digestion and gasification.
Now, I will move to a methodology part of this presentation. I would like to illustrate this point by showing you the diagram of significant parameters. The fuel gas pathway and polymer electrolyte fuel cell combination were highlighted based on best performance across 4 parameters. 1. Fuel cell output. 2. Fuel gas demand. 3. Raw gas demand. And 4. Raw feedstock demand. Please expect each pathway performance for producing 1 megawatt-hour of electrical output. Now, let's have a look at this diagram that demonstrates how the raw biomass feedstock converts to the fuel gas with products undergoing 4 stages of conversion. Transform stage 1, which converts the raw biomass to usable chemical feedstock by refinement process. And stage 2, which converts the feedstock to raw gas by biomass conversion process. Stage 3, which converts the raw gas to fuel gas by cleanup reforming process. And final, stage 4, which uses fuel gas as a fuel in the fuel cell. The amount of biomass feedstock and fuel gas was required at each stage was calculated starting from stage 4 and working backwards. For stage 4, the fuel cell output required to produce a function unit of 1 megawatt-hour electrical output was calculated with this equation. The fuel cell output was then used to determine the fuel gas demand by using this equation. The raw gas demand was calculated for stage 3. To determine how many kilograms of unprocessed raw gas are produced per megawatt-hour of feedstock by using this equation. The chemical feedstock demand was calculated for stage 2 using the raw gas divided by the pathway conversion process efficiency. This corresponds to the chemical conversion reaction in the raw waste biomass, which vary with each pathway. The calculation for stage 1 can be made to determine the amount of raw feedstock demand required by using this equation. The amount of biomass feedstock and fuel gas of anaerobic digestion and gasification pathway was compared for consideration that this pathway is more efficient. Now that I have given you an overview of methodology for this experiment, let's move on to the next part, which is the finding of this experiment.
Now, I will move to finding part of this presentation. Let's have a look at the summary table. This table shows the composition amount, the amount of raw material in different methods. For producing 1 megawatt-hour of fuel cell electrical output, as you can see here, first method is anaerobic digestion. It uses about 870 kg per megawatt-hour of feedstock demand, 650 kg per megawatt-hour of raw gas demand, and 66 kg per megawatt-hour of fuel gas demand. Whereas the second method, gasification, uses about 2,200 kg per megawatt-hour of feedstock demand, 1,000 kg per megawatt-hour of raw gas demand, and 66 kg per megawatt-hour of fuel gas demand to produce fuel cell. And the pathway for producing fuel cell data in the table can be plotted to the graph as follows. From this graph, we can see that anaerobic digestion uses less both feedstock and raw gas demand than gasification. Therefore, it can be concluded that anaerobic digestion is the method that is more efficient than the gasification method to produce the hydrogen. Now, let's take a look at the implication of this data.
Let's continue. Previously, we have accepted the hydrogen. Now, we will take advantage of it. Fuel cells have the power to change the outer world. We are dedicated to make fuel cell technology a reality to replace the internal combustion engine in your car with a clean, white pollution-free fuel cell engine. Fuel cell powered cars just look like other cars on the road today, but they are cleaner, quieter, and more efficient. A fuel cell engine consists of photon exchange membrane or PEMFC module, which can produce the electricity to your car. PEMFC are used primarily in transportation applications due to their fast startup time and operating temperature of 50 to 100 Celsius and rates of efficiency 35 to 60%. PEMFC are particularly suitable for use in passenger vehicles such as cars and bus. The fuel cell technology, a process known as reverse electrolysis takes place, in which hydrogen reacts with oxygen in fuel cell. The hydrogen comes from one or more tanks built in the FCEV, while the oxygen comes from the ambient air. The only result of this reaction are electrical energy, heat, and water, which is emitted through the exhaust as water vapor. Next, I will pass you over to Poom, who will conclude the presentation.
We are now approaching the end of our presentation. In conclusion, I'd like to summarize the main points. In the beginning, we give you an overview of basic knowledge of hydrogen production. After that, we explain to you about methodology of hydrogen production in each way. In finally, we have also given you that anaerobic digestion is the best way. And finally, we will discuss the implication reaping the hydrogen that we have from anaerobic digestion process, convert to the energy by PEMFC, and we use it for cars. We hope you will find our presentation useful. This is all we want to present. Let's bring the presentation to the end. Thank you for your attention.